Subsea pipelines are critical infrastructure used in the offshore oil and gas industry to transport hydrocarbons, chemicals and other materials between offshore platforms, subsea facilities and onshore terminals. These pipelines operate under extreme environmental conditions, making safety, design and operational reliability paramount. Below is an overview of their design process, safety considerations and critical technical aspects. Safety in subsea pipeline systems involves protecting human lives, the environment and assets. Key considerations include material selection, high-strength, corrosion-resistant materials to withstand harsh marine environments. Cathodic protection prevents corrosion through sacrificial anodes or impressed current systems. Leak detection systems. Continuous monitoring using advanced sensors and SCADA systems. Emergency shutdown mechanisms. Rapid closure systems to contain leakage. Compliance with standards, adhering to codes like DNV-GL, API and API to ensure safety and durability. The design process includes several steps to ensure functionality, stability and cost efficiency. Site surveys. Detailed geotechnical and geophysical surveys of the seabed to determine optimal routes. Hydrodynamic analysis, understanding wave, current and tidal effects. Stress analysis, evaluating internal and external pressures, temperature and mechanical stresses. Material and coating selection, ensuring durability, corrosion resistance and thermal insulation. Engineering simulations, finite element analysis FEA, for structural integrity under extreme conditions. Internal pressure. Generated by the fluid being transported, leading to hoop stress and longitudinal stress within the pipeline. Proper wall thickness is critical to prevent bursting. External pressure. Subsea pipelines are subjected to hydrostatic pressure proportional to water depth. This can cause buckling or collapse, necessitating accurate pressure containment design. The installation of subsea pipelines involves lowering them to the seabed using specialized equipment like stingers or pipe-laying vessels. Controlled lowering ensures the pipeline is laid along the planned route with minimal stress. Tension control maintains structural integrity during deployment. Modern vessels with GPS-guided systems ensure precise placement through dynamic positioning. The stability of pipelines on the seabed is vital to resist hydrodynamic forces and prevent movement. The objectives include preventing lateral displacement due to currents or waves and ensuring the pipeline remains in position during and after installation. Static analysis involves assessing forces acting on the pipeline, including self-weight, buoyancy, and external hydrodynamic forces. Additional stabilization methods include rock dumping, concrete matrices, or trenching. Pipeline flotation occurs when buoyant forces overcome the pipeline's weight, causing it to rise. Preventative measures include increasing the pipeline's submerged weight using concrete coatings or weight collars, ensuring trenching or burial in areas with soft sediments to counteract uplift forces. Fatigue failure in subsea pipelines can occur due to repeated cyclic loading from waves, currents, or operational pressures. Key design considerations: fatigue life estimation using SN curves and Miner's rule. Weld joint analysis, ensuring welds are free of defects that can initiate fatigue cracks. Flexible risers designed to accommodate stress variations without failure. The hook and pull installation technique is used in shallow waters. A pipeline is hooked to a winch or pulling device on shore or on a vessel. It is gradually pulled into position, ensuring minimal stress and deformation. This method is typically used for smaller pipelines over short distances. DNV-GL pipeline standards, submarine pipeline systems, DNV-GL STF 101, American Petroleum Institute, recommended practice for subsea pipeline design, by Subsea Engineering Handbook, Gulf Professional Publishing 2012, Palmer & King, Subsea Pipeline Engineering, Penwell Books 2008, International Marine Contractors Association, Guidelines for Offshore Pipeline Installation.